Okay, I promised you a video where I'd show you how to operate the calculator for the chi-square goodness of fit test. So this is the problem from the videos that precede us that we've worked out. You've seen the solution worked out on the board. You've seen everything written down. So I just wanted to show you the keystrokes on the calculator. They're going to show us how to do how to conduct the chi-square test on the calculator. So recall, we've already checked the conditions. We've already done all that stuff. But here we have our expected counts and we have our observed data. Remember, we do a chi-square goodness of fit test when we have one sample, categorical variable is our parameter of interest, and the distribution of it with more than one category. So we have one row of observed data. Basically, we're going to put that in a list on the calculator. So we're going to go to the calculator. We're going to hit Stat. We're going to hit Edit. And in L1, go ahead and put in L1, we're going to put our observed data. The calculator will default this when we run the test that L1 will be, and you'll have to change it if you don't put the observed data in L1. We're going to put in what we had for our freshmen. We'll make sure we put this in order. So 12, 14, 20, and 14. 12, 14, 20, and 14. And then our expected counts are going to go in list 2 in order corresponding to the ones from the observed data. So these are all going to be 15s. When you run this test, you have to make sure that the same number of entries are in your L1, it's in your L2, or else the calculator will throw you an error. So now we're going to do second mode to get out of this. We're going to go and run our hypothesis test. So we're going to hit Stat again, scroll over to Test, scroll down to Chi Square GOF. And remember, the chi squared is the Greek letter chi, so it looks like an X, but chi squared GOF, that's the chi-square goodness of fit test. Hit enter. Now our observed list was list 1, our expected list was list 2. Our degrees of freedom, remember the number of categories minus 1, so degrees of freedom here are going to be 3. And then we're going to tell it to calculate. It gives us our chi-squared value, our p-value, degrees of freedom, and the contribution each of these observed data made to our chi-squared value. So if we look at that, I don't know if we can look at it on this calculator, but you can highlight that and scroll through there and see what each contribution was. So recall that we do the chi-squared test statistic is the observed minus the expected squared divided by the expected. And so that gives me 9 over 15, negative 3 squared is 9, 9 over 15, that's where this 0.6 came from. Then this would end up being 1 squared over 15. We needed 14 minus 15 squared it. So 0.0666. And then this would be 5 squared over 15, 25. So there's going to be more contribution to the chi-squared value we get here. But anyway, that's what the contribution list is for on there. But that's how you conduct the chi-square test. It gives you the p-value. Then we can, in our conclusion, tie the chi-square. We need to remember, write the chi-squared value down and a p-value down and the degrees of freedom in our list of, or in our calculations section of our solution. And then we tie the p-value to alpha, and that's how we decide whether or not to reject or fail to reject the null hypothesis. But that's how you run a chi-square goodness of fit test on a calculator.